This video is for review quiz 3.3 and 3.4. First question, we want to do long division here, so let's set that up. We have the numerator, 14x squared plus 12x minus 20, divided by the denominator, which is x plus 4. X plus 4 is in the correct form where synthetic division would work out very nicely here. If you can use synthetic division, do so. It's going to be easier. For long division, we're going to take the first term, always the first terms, and we're going to divide them. So we get 3x cubed divided by x. That gives us 3x squared. So that goes on top. And then the top thing gets distributed into this term. So 3x squared times x is 3x cubed. 3x squared times 4 is 12x squared. This gets subtracted from the polynomial. I wrote it specifically this way so that the like terms are in a column, and we can just subtract going down. So 3x cubed minus 3x cubed is 0. You should expect a 0 for the first term. Okay, and then 14 minus 12 is plus 2x squared. I'm going to bring down this next term, and we can continue. So 2x squared divided by x, we get 2x squared divided by x is 2x. And once again, multiply it through. So 2x squared times x is 2x squared. 2x squared times 4 is 8x. We can subtract. 2x squared minus 2x squared is 0. Once again, you should expect that. 12x minus 8x is going to be positive 4x. Bring in the last term in the polynomial, and once again, divide. 4x divided by x is just 4. Distribute the 4 into the x plus 4. That's going to give us 4x. 4 times x is 4x. 4 times 4 is 16. We're going to subtract. We get 0, which is what we expected, and 20 minus 16 is 4. There's no other x to divide out, right? If I took the 4 divided by x, this is just a rational function. There's nothing else we can do there. There's no nice division, so that's kind of where we can stop. And this is our remainder. So our answer is going to be the numerator, 3x to the power of 2 plus 2x plus 4. And we have an additional remainder of 4 divided by the same denominator as the original division. So it's going to be this thing here, the x plus 4, which you see here in the denominator, x plus 4. This should be our answer. Okay, let me see if I made a sign error real quick. And of course, when I brought down the negative 20, I wrote positive 20. That's where the minus 20 is there. Minus 20 minus 16 is going to be 36, negative 36. That's our remainder. Check that. And now we have it correct. So it's very easy to make a simple sign error. I mean, that was one sign error, and that got my remainder wrong. So double check your signs. I should have been doing that. It's very easy to make a mistake like that. All right, let's move on. We want synthetic division here. Now this is a little bit, this is written a little bit weird. I'm going to rearrange this so that's the highest power to lowest power. We have x to the 4th minus 7x cubed, then plus 2x squared minus 14x. Now I'm also going to add in this last term that we don't have, which is the constant term, the 0, or just the number by itself. This is going to be divided by not 7 plus x, but x plus 7. Okay, it says use synthetic division. This is a great candidate for that because we have x plus something or x minus c on bottom. Whatever that c is, this is in this case is going to be what makes the bottom 0. So negative 7 plus 7 is 0. We're going to synthetic divide using negative 7. It's kind of the 0 that you use to divide, not the like the 7 and the x plus 7. It's the 0 you get from it. So it'd be negative 7 plus 7 gives you 0. So Now all we need to do is look at the coefficient. Of course, we have 1x to the fourth, then minus 7x cubed, then plus 2x squared, minus 14x, and 0. So if this were a constant, or I should say a 0 of this polynomial, we would expect a 0 right here as a remainder, but we don't know that. We're just going to continue by doing the synthetic division. So you always add going down. 1 plus nothing is just 1. That's always the first step. Just bring down the first term. Then you multiply going up. So add and then multiply. So 1 times, and you always multiply by the term in the box here, the -7. So 1 times -7 is -7. Add going down, -7 plus -7 is -14. Then multiply, so -14 times -7, use a calculator, gives us positive, because negative times negative is positive, and 7 times 14 is 98. Add going down, we get 100. 100 times -7 is -700. Add going down, -714. And finally, we're going to multiply going diagonally up. Negative times negative is positive, and we get 4998. Add going down, that is the remainder. So it's not 0, which means this is not a perfect factor, a factor of this polynomial, but it does give us the division there. So you always add going up. So this first term besides the next to the remainder, that's going to be the constant term. So we have -714. And the next one's going to start going up by x's. So we get 100x. Then this one's going to give us -14x squared. And finally, this one's going to give us 1x cubed. So highest power is going to be x, so x cubed, minus 14x squared, plus 100x, minus 714. And the remainder is going to go in this upward box here. And you'll notice that we went from a 4th power polynomial, divided out an x, and we're left with a 3rd power polynomial. You should always expect that. If we're dividing by a squared term, then we should expect it going down 2, but in this case, we're dividing by a linear term, so it's just going to go down by 1. Let's check it. And that's correct. Let's move on. Okay, we've got a polynomial here, and we have an incomplete graph, and it's asking us to find all the zeros and then figure out what graph it's going to be out of one of these 4 things. You could, of course, just graph this thing to figure out which one, but you don't need to. It's actually going to be quite easy to figure out which one it is. And first off, we have to find all the zeros. So this is a cubic, so what we could try is one thing we do know how to do is factoring by grouping. Let's try that first. If we can do that, then it's going to be a lot easier. From the first 2 terms, I'm going to take out a -x squared. That gives me x minus 4. The next 2, I can take out a 3, positive 3. Gives me 5x minus 6. Yeah. And you can see the thing in parentheses is not the same. So this isn't going to work, this factoring by grouping. So let's go back to the drawing board. Well, we have a partial graph. I don't know why you have a partial graph, but we do have one. And what's nice about this is it actually shows us where the graph crosses the x-axis. Well, where it crosses the x-axis, that's a 0 of the polynomial. And we can divide that out to find the rest of them. So this graph is written down here at the bottom. It says -5 to 0 by 1s. So it's going to be -5, -4, -3. -2, -1, 0. So this is the y-axis right here. And this is -3 then. So it says that x equal to -3 is a 0 of this polynomial. That means we should be able to divide out evenly a factor of x plus 3, because -3 plus 3 is 0. If you plug that in, you get 0, right? So let's take the polynomial, -x cubed plus 4x squared plus 15x minus 18, and divide out the x plus 3. Why should we do this? Because if we go from a cubic and divide out a single x, that's going to take us to a quadratic, and we can use the AC method, we could use quadratic formula, we could use any number of tools that we have to find the rest of the zeros. Quadratics are very easy to work with, so once you get there, you're pretty much good to go. And this process of dividing out this factor will get us there. Now this is a great candidate once again for synthetic division. The 0 is -3, and the coefficients are -1, 4, 15, and -18. Let's divide out, or let's actually do this thing to divide out this this factor. Bring on the first term, then multiply going diagonally up. -1 times -3 is +3. 4 plus 3 is 7. 7 times -3 is -21. Add going down, we get -6. And -6 times -3 is +18. Add going down, we get 0. And this proves to us that yes, we did this correctly. This is a factor because we get a remainder of 0. It divides evenly. And what remains, well, we went from a cubic, now we have a quadratic, x squared, x, and then x to the 0, or just no x there. We get -x squared plus 7x minus 6. I can divide out this negative. It's a little awkward having a negative in front, so divide it out. And now I have a quadratic that I can factor. Let's try the AC method first. A times c is +6. B is -7. Two numbers that add to give 6. Sorry, multiply to give +6, add to give -7. It's going to be -6 and -1. -6 times -1 is +6, and -6 plus -1 is -7. A is 1 here, so we can immediately factor this down into x minus 6 and x minus 1. We have 3 zeros. The -3 that we started with from the graph, and then these two. From the first one we get +6, 6 minus 6 is 0, and then 1 minus 1 is 0, so +1. We have -3, 6, and 1. Those are all of these zeros for this polynomial. And to look at the graph, well, we know this portion, this is on the -x side, so we can immediately factor out b. It doesn't look at anything like this. Well, I guess it could. It could be b, I suppose. Could be a. I guess it technically could be all of these, but let's look at the zeros here. Oh, well, we know it's not this one. This one only has 2 zeros. We have 3 zeros, so it can't be this one, it can't be this one. So it could be b or d. Which one is it? Well, let's see here. We have -3, 1, 2, -3. This -3 should be a 0, and this one doesn't have it there, so it's not b. D has -3, +1, and +6. So this one has the right graph. It has the right look here. This one looks much flatter, but that's just because of the y-axis scaling. This one goes from -65 to 60. This one goes from -35 to 30. So that's why it looks much shallower. This one looks very steep, but it has the right zeros, and that's all that really matters. And that's correct. Let's move on to the next one. All right, very similar. We have this polynomial, and we have a graph here. This partial graph here goes from 0 to 1 in 0.25. So we have 0.25, 0.5, 0.75, 1. So 0.5 or 0.5 is a 0 of this. Let me write that down. 0.5. That means that x minus 0.5 is a factor of this polynomial, which of course means we can divide it out. Let's do that first. We have, this is really synthetic division, so I'm just going to write that out. 0.5 is the 0. We have 2 from the first one, the -13, 10, -26, and +12. I'm just taking the coefficients from our f of x and putting in the synthetic division. Okay, add going down, multiply going up. 0.5 times 2 is 1. Is negative 12. 0.5 times negative 12 is negative 6. Gives us 4. 0.5 times 4 is positive 2. Negative 24. 0.5 times negative 24 is negative 12. And that does indeed give us 0. Okay, now we have a cubic here. This is going to be 2x cubed minus 12x squared plus 4x minus 24. This is not a quadratic, so we couldn't necessarily, what we want to do is try to divide out another factor if possible, because that gives us a quadratic. But we do have a cubic here, and we do know one method of factoring cubics, namely factoring by grouping. So let's try that. Oh, no, I can take out an x squared as well from that. That gives me x minus 6. Divide out a positive 4 here, gives me x minus 6. So these are the same, so we can do this. Plus 4, and then we get x minus 6. And this one, you can actually divide out a 2 from there if you want. And this is a sum of two squares. 2 squared is just the square root of 2 squared. And that is prime, meaning you can't factor it over real numbers. So it's not going to add any zeros to it. We did find a 0 here. This one's going to be positive 6. So we know there are zeros of positive 6. And it says it wants fractions. So instead of 0.5, it's going to be 1 over 2. There's not going to be any real zeros from this. There are, however, complex zeros. And so we're going to find the complex zeros by using quadratic formula. So a equals 1, b equals 0, because we don't have a bx in this this guy here, and c equals 2. So quadratic formula: b squared minus 4ac square root of that all over 2 times a. Plug a, b, and c into there and simplify. B is 0, so that this just goes away to 0. That's just going to be 0 as well. So we get plus or minus the square root of 4 times a times c. That's going to be negative 8. All over 2 times a, 2 times 1, so 2. Okay, we have 8 here. We can simplify this by taking out that negative. Square root of 8 I over 2. And 8 is 4 times 2, which is 2 times 2. I have a pair of 2's and a 2 that remains on the inside from simplifying that radical. 2 root 2i over 2. Of course, the 2's cancel. This gives us plus or minus root 2i. So those are the two complex zeros we have here. Plus or minus root 2i. Make sure the I is not underneath the square root. That's an easy thing to mistake. That's why I always write these little lips on my square root symbol so that you can see where they end. All right, now these complex zeros do not give us a 0 in the graph. We do, however, have 2 real zeros, 6 and 1/2. So it should cross the x-axis twice, but not more than twice. This one crosses twice, this one crosses twice, this one crosses twice. This one looks like it crosses 4 times. Let me see if I can zoom in on it. 1, 2, 3, 4. Yeah, it's not this one. That one crosses 4 times. Let's see about C. Yep, that's twice. And we had, what was it? 0.5 and, yeah, 0.5 and 6. So this looks like it's going to be 1, 2, 3, 4, 5, 6. These are not 0.5 and 6, so this one's not it either. Let's look at B. That looks like 0.5. 1, 2, 3, 4, 5, 6. So it could be B, I think. It could be B. This one's at negative 0.5 and something a little bit more than 6. So it's going to be B is our answer. And that's correct.